Atoms will bond because they want a full outer layer. This makes them stable and happy. Most involves 8, but hydrogen and helium only need 2 because they are really, really small and they do not hold any more. We express these in electron dot diagrams, showing valence electrons as dots around the symbol. Compass points north, south, east, west. You can change at any time as the electrons always move anyway. Or structural formulas where the bonds are shown as lines and not electrons as dots, but bonds as lines. We will be dealing with both of these types of diagrams now. And there's a little picture that I made one year and I just liked it, so there it is. Now, basically, you write the symbol, you get the valence electrons off of the table, they're at the top of columns, place the dots as electrons at the compass points, north, south, east, west. Doesn't really matter, and we can change it whenever we want, and there we go. So be careful. First off, when we're looking at your table, each column has one more valence electron. This will determine the bonding, and you should mark your table with the numbers. We are not going to look at these, as these are ions only. We are not going to focus on these at all. None of the transition metals, none of the intertransition metals, they are not going to covalently bond. So we're going to have 1, 2, 3, 4, 5, 6, 7, and typically 8 dots. So you are going to need to mark your table with this 1, 2, 3, 4, 5, 6, 7, 8, because that will tell you how many dots you're going to need to put on there. Of course, there's an exception to this, because there's always an exception, and that is helium. Helium only holds 2 dots, and they start out pre-paired. So helium's the weird one, but everything else works in a very similar, predictable fashion. So at some point, you're going to need to mark your table with 1, 2, 3, 4, 5, 6, 7, 8, and then you probably want to mark helium as being special, where it has 2 that are already bonded. We are not going to look at the stuff in the middle because that is ionic only, and this is covalent bonding that we are dealing with. Boom, doing it. So this table is in your notes, and it's already pre-filled for you. But I am going to do something slightly different with this. Where are you? There you go. Hey, buddy. There we go. I want my pen. Okay. So, as per what I just said, the number of valence electrons is something that you can look up. Hydrogen is 1, beryllium 2, boron 3, carbon 4, nitrogen 5, oxygen, well, hold up. Did I do that? Yeah, I did that right. Oxygen 6, fluorine is 7, and neon is 8. Again, these are outer electrons, so these are ones you're going to see on the outside layer, which determines bonding. Because of this, we only have 1 dot somewhere around our hydrogen. Now remember, we're going to want this to be north, south, east, or west. Okay, your compass points, like that. So I'm going to put 1 dot either north, south, east, or west. I'm going to put mine north because I feel like it. Then I have 2 dots. I'm going to do north, and I'm going to do east. I could easily have done north and south or west and east. It doesn't matter as long as I have 2 dots that are not together, because unpaired is always done first. So 1, 2, 3, 1, 2, 3, 4, and then it gets fun. For 5, we do 1, 2, 3, 4, but then we do a 5th dot as a pair. Ooh, that was really crappy. Messed that up. There you go. That's better. So a 1 pair, 3 unpaired. So 1 unpaired, 2 unpaired, 3 unpaired, 4 unpaired, 3 unpaired, 1 paired, and then oxygen is 1, 2, 3, 4, 5, and I'll do mine here for 6. And for 7, fluorine is 1, 2, 3, 4, 5, 6, 7. It's sloppy. I don't like that. We don't want to be sloppy with this. So I'll erase that and redo it to make it better. 1, 2, 3, 4, 5, 6, 7. Again, doesn't matter which ones I do, just that there are 3 paired, 1 unpaired. Now for neon's easy, you get 8. But notice, even though I know there's going to be 8, even though I know this is all going to be full up, you want to do the unpaired first, and then go back and do the paired. Get yourself trained to do that, and life will be easy. So these are the patterns. You've got 1 unpaired, 2 unpaired, 3 unpaired, 4 unpaired, 3 unpaired, 1 paired, 2 unpaired, 2 paired, 1 unpaired, 3 paired, and 4 paired. What does this matter? Because it matters for bonds. Bonds are unpaired. The more unpaired electrons you have, the more bonds. So these unpaired electrons, like this one, is a bond. There's 1 bond, 2 bonds, 3 bonds, 4 bonds. But look at nitrogen. You've got 1, 2, 3 possible bonds, no bonds where the pair is. No bonds that way. So you've got 3 bonds then. 1, 2, 3, 4, 3, and then you get 2, 1, and 0, as there is no bonds with our neon. Our noble gases do not bond because they're already happy and full. So again, you can notice that whenever there is an unpaired, you have a chance to bond. This is super important. You need to take a look at that and keep that in mind. So that's how that goes. And if you click through here, if I am correct, it gives you some hints to the side, and then it just gives you everything because animating one at a time was going to take way too long and I didn't do it. So there you go. Plus, you just saw that video. Maybe I'll even link it there. You can see Bozeman Science go over it. They do a good job if you want to hear somebody else do this other than me. Atoms will bond until all participants have maximum valence electrons. Shared electrons count toward both of the participants in a compound. Single bonds share 2, double bonds share 4, and triple bonds share 6 electrons. So 2, 4, and 6. Yes, there is a quadruple bond. No, it is not common. No, it will never be used in this class. So don't worry about it. We're just going to go up to triples. Because honestly, a quadruple bond in nature is incredibly rare, does not happen often, and you are unlikely to ever see it anyway, so let's not bother. This is one of the oldest notes I've ever done because it's so freaking good. I've actually given this to college professors as well. I'm pretty proud of it. This is how you bond. Okay, the steps are listed to the left. What's on the paper is in the middle, and what's in your head is at the end. And I think it's what's in your head is the thing that really makes this good. So you should take a look at this. This should be something that you have at your fingertips, basically, when you do this. Remember, all your tests and quizzes, even the final, is open note. It's just not open friend. If I notice your answers are way too similar, then I'll launch an investigation, and if my investigation finds malfeasance or cheating, I will just zero your scores and let you argue it with my bosses. Now, over here, step 1, write the symbol. Just think of the table, look at the symbol, write it down on the paper. Then figure out the valence electrons that you just wrote down. Chlorine is in the 17th column, which is 7 valence electrons, so we're going to have 7 dots. You do your 4 unpaired first, north, south, east, west. So 1, 2, 3, 4. Then the remaining electrons become paired. I have 3 left in my head. Now I have 0 left. Unpaired electrons can form a bond. There is 1 bond possible. Keep that in my head. I put the other element there. The bond dots should hug their atoms. Notice they're in tight little squares. Each element should have 8 dots, except for hydrogen, helium, which only need 2. And if we then do structural formulas, the shared dots become lines. You don't need to write any dots, at least not in this class. Your college professor may have you write dots. I have seen a couple professors decide that's what they want to do now. Well, do whatever your college professor says. Never argue with them about what your high school teacher said. That is a losing battle. They control your grades. If I controlled your grades, I would allow you to argue, but I do not, when you're in college. So we've got our 2 drawing methods, electron dot and structural, and we can move these pieces whenever. This is an example of them. You can see the electron dot here. I've got bromine and bromine. You can see that the red bromine has 7 dots. The blue bromine has 7 dots. They have 2 dots that are shared between them. If I count around my bromines, 1, 2, 3, 4, 5, 6, 7, 8, it's great. 1, 2, 3, 4, 5, 6, 7, 8, it's great. Both of these bromines are happy. There's one line in between them because there's 2 multicolored dots that they share. So 2 shared dots, 1 line. Here you've got hydrogen. Hydrogen only has 2 dots, but it only needs 2 dots, and the chlorine has its normal 8. Again, a single bond between them. Silicon, nitrogen, and hydrogen is a much harder one, as there needs to be 3 bonds between the silicon and the nitrogen, and 1 between the silicon and the hydrogen. It's the only configuration that works. You get a triple bond and a single, and this is methane, CH4, 1C surrounded by hydrogens, your H's. All right, so there's your electron dot, all dots. There's your structural, lines only. Now, to go over this, and I believe I have a video of me doing this from last year, but hey, why not live the life? So fluorine is going to be my example. My first fluorine, I'm going to write on my board. I'm sorry, I need to be 2. I'm going to write an F. And then, actually, no. I did find out that 4 is better. So I have my first fluorine, which I'm going to write to the left so that I have room at the right to write my second fluorine. Fluorine, if I look on the table, has 7 dots. Now, I want my other one to be to its right, to its east. So I'm going to do 1, 2, 3, 4 dots like normal. Then I'm going to do that right away. Then I start pairing. Here's my 5. Now, normally I would put my 6 here because I like going clockwise, but I don't want to put my 6 here because I want to put my other fluorine there. So I want this to be my active bond. So I put my next one here and my last one there. 1, 2, 3, 4, 5, 6, 7 dots with my open space over this way. That allows me then to put my other fluorine here. This fluorine is also going to give 7 dots. So here's my first dot. Pro tip, make the bond right away. So there's 1, 2, 3, 4, 5, 6, 7 dots. You'll notice 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Both of these are now happy. They've got 8 dots each, and I've got 1 bond between them. Structural wise, I've got my blue fluorine, my red fluorine, and a single bond connecting the 2 because there are 2. So because there were 2 dots, that becomes 1 line. So 2 dots becomes 1 line, boom, structural. Now, oxygen, draw my oxygen. 1, 2, 3, 4, 5. I want to put my other oxygen here, so I'm going to put my 6 dot that way. Because oxygen has 6 dots based off the table. Put my other oxygen next to it. I know it was a little far away, but okay, that'll be fine. That's a bad place to put it. I'll put below. 1, 2, 3, 4, 5, 6 dots. Now my bond here is good, but if I count 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, neither of these have 8, so right now they're not happy. They're not happy at all. We want to make them happy. Now, to make them happy, you may notice that there is a spare dot on each of them, right there. That means there can be 1 bond each of these can make, so why not make it with each other? To draw a second bond, what you want to do is erase one, write one. You erase a dot, then you write a dot. So I erased an orange, I write an orange. I erase a green, I write a green. Like this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Suddenly, we're not unhappy. We're happy. Both sets had 8, and that is great. Now, when I draw my structural formula between my 2 oxygens, I am sharing not 2 dots, but 4 dots are shared, which means this is a double bond, which looks like an equal sign when it's written horizontally. So there is your double bond with oxygens. Now, at this point, I would like you to try nitrogen on your scrap paper, etc. I will tell you that if you did everything proper, you should know that nitrogen has 5 valence electrons because it was the number 5 that we wrote at the top of our table. I want you to try nitrogen over the next 2 minutes, and then I will show you. But this is a chance for you to see if you've been paying attention and you understand how to draw dots and how to connect bonds to each other. 2 minutes, good luck. Sorry about that. We have 1 minute remaining. Just going to give you 30 extra seconds. Okay, so we have 5 dots. 5 dots when it comes to this. So, let's get this set up properly. So my first nitrogen that I write has 1, 2, 3, 4, 5 dots. And my second nitrogen that I'm going to write has 1, 2, 3, 4, 5 dots. Notice I made the bond right away. Now you'll notice there's only 6 dots around each nitrogen. That's bad. But we have 2 possible bonds that we can do. We can do a bond between here, and we can do a bond with these 2. So we've got 2 different bond opportunities, so let's do them and see if that solves our problem. So erase 1. I erased one of the pink dots, and I write it, erase 1, write 1. Okay, then I get a matching orange dot. Erase 1, write 1. Still not done, but I've got 1, 2, 3, 4, 5, 6, 7, and 7. Well, let's do that again then. Ooh, little too much erasure. Erase one of my pinks, write a pink. Then erase one of the oranges, write the orange. And there we go. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8 is great. So in this case, I have got nitrogen and nitrogen, but what they have is not a single bond, not a double bond, but a triple bond. 6 dots makes a triple bond. So here we go. Single bond, double bond, triple bond. Beautiful. Now, so far, all of these have been diatomic or social elements, meaning it's the 2 copies of the same element. We can have elements of different styles with as well. Water and CO2 as my examples. Okay, now, pro tip, water and O, hydrogen and oxygen. Oxygen makes 2 bonds, whereas hydrogen makes 1 bond. So you always want to do the one with the most bonds first. You want to do it first, and you want to do it in the center. So I want to start by putting my oxygen in the center. And oxygen has 6 dots, 1, 2, 3, 4, 5, 6. And then I want to put my hydrogens on. Now, each hydrogen only gives 1 dot. So I'm going to put my first hydrogen here, gives 1 dot. And then I'm going to put my second hydrogen down here. It gives 1 dot. And there we go. 8 around the oxygens, 2 around each hydrogen, which makes it great. Now, pro tip, hydrogen is always last. Out of all the elements, hydrogen is the easiest to put in, so always do that one last. And carbon is the most important, so you always want to do carbons first. So carbons first, hydrogens last, just as a pro tip. Now, when I draw this structural formula, I've got H bonded to an O bonded to an H. Now, you might be like, Mr. D, this one had H, O, H. Which of these is right? Well, they're both right. Both right. That's correct. That's correct, because remember, north, south, east, west doesn't matter, and we can change it any time. What matters is paired, unpaired, and bonded. And in this case, we've got 2 single bonds from hydrogen to oxygen either way. So they both work. Now, carbon dioxide is a bit trickier. We're going to start with our carbon, which has 1, 2, 3, 4. Then I'm going to have my oxygen, which has 1, 2, 3, 4, 5. Notice no one else here. 6. Say 2, 2, and 2. Then I'm going to have my last oxygen over here. 1, make the bond first. 2, 3, 4, 5, 6. Now you'll notice each of the oxygens have 7 dots. The carbon has 6 dots, but there is available bonding opportunities here and there. So we want to make those bonding opportunities because it turns out you're going to need double bonds. When we do this, remember, we erase one, write one. That is how we always go. So I erase a blue, I write a blue. I erase a purple, I write a purple. I also highly recommend color coding. Really, really, really recommend it. It just makes it a lot easier as you are learning. When you get good at this, then you can choose not to color code. But again, you are learning. So color code. I erased another purple, write another purple. Then I erased my red, and I write a red. You will notice 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Everyone has 8. Everyone is happy. So this is a good, stable molecule. We know CO2 works. To write this in our structural manner, we've got our 2 oxygens. We've got our carbon in the middle. Remember, the thing with the most bonds is typically written in the middle. And 4 dots equals a double bond. So O, double bond C, double bond O. Beautiful. That is carbon dioxide in its proper structural form. So that's your crash course on bonding. Now there's all sorts of bonding practice that you can do here. You can do I2OCl2, and then it will show you the answers, both electron dot and structural, and you can just keep looking at this. Sometimes I have notes to help you out, so please click through and try all of these.